to this YouTube tutorial channel. Today we're having a chemistry content class, a class on practical chemistry. You're still on Best Science Brain YouTube. If you are seeing this video for the very first time, or you are not subscribed to the video, to the channel, please go up or step up to the channel's name, Best Science Brain. You're going to see a tiny bell written subscription, then tap on the bell only once and get subscribed to the channel, and then you'll be seeing our videos from time to time. You will enjoy our tutorial and you will learn something new every time you watch our video. So when you subscribe, our video will be coming to you from time to time as notification. You see it coming to your phone. If you don't subscribe, you will not be seeing our videos. You will only be searching for the videos. So this is the best channel you can have for chemistry, physics, and further mathematics tutorial, online live lectures. So for today, our focus will be on chemistry content, practical chemistry. So today we are looking at qualitative inorganic analysis. Qualitative inorganic analysis. So what is qualitative analysis? So in chemistry, we deal with two major types of analysis. One is called qualitative, the other is called quantitative analysis. So qualitative analysis is the aspect of practical chemistry that identify the constituents of a chemical substance. So if you want to find out what a chemical substance is made up of, that aspect of chemistry is called qualitative analysis. What component or what are the constituents of a chemical compound, for example, an unknown compound. For instance, if a man is caught in an airport carrying a hard drug, so maybe white substance which is suspected to be a hard drug, the only way to know that the person is the person can claim that he's taking that what he has is sugar. He can still claim that what he has is common salt, that it's not a hard drug. So the only way to identify that that substance is a hard drug is to carry out a chemical analysis, or what we call a quality analysis, know the elements that make up the hard drug, and of course carry out what we call a structural analysis, know the compound, whether the compound the person is carrying or the substance is actually a hard drug or not. So in chemistry, we are often faced with identification of cations and anions, that is, knowing the constituents that make up a chemical substance. This tutorial lesson is meant for those in SS3 and SS2, Senior Secondary 3 and Senior Secondary 2, as well as those in the first and second years in higher institution. So this is a core practical aspect of inorganic chemistry. Now, our focus, there are many reagents or chemicals we can use to identify cations in chemistry, of which we have is sodium hydroxide, one of the reagents. We can still use another reagent called aqueous ammonia to identify cations. So there are many reagents we can use to identify cations. The two common ones are sodium hydroxide, NaOH, and aqueous ammonia. But our focus today is on the chemical identification of cations using sodium hydroxide. Then, before we introduce the word cation, we know that a salt is a chemical substance which is formed from an acid when the replaceable or the ionizable ions in acid are replaced by a cation. We have a salt produced. A salt contains a simple salt or a normal salt contains a cation and an anion. For instance, we have sodium chloride is a salt, copper 2 sulfate is a salt, iron 2 chloride is a salt. Now if you look at these salts, if we ionize them being soluble salt, we now have sodium ion breaking from chloride ion. On this one, we have copper 2 ion splitting from sulfate ion. Iron 3 ion splitting from chloride ion. So the positive ions are called cations. The positive ions are called cations. Why are they called cations? If you could reflect back to your topic, electrolysis. Cations are those protions that move to the cathode during electrolysis. So that is why we call the protions or the metallic ion called them cations. Now, assuming we have an unknown substance labeled S, and that substance could be CuSO4. Our interest is this. How do we know that this unknown substance contains copper since we don't know its name? Or we have an unknown substance labeled C, and that substance is iron trichloride, but we don't know that it is actually iron trichloride. How do we identify that that substance contains iron trication inside it? So that is what this practical is all about. How to know the cation present in an unknown salt sample using sodium hydroxide. For this video or for this content, we're going to use sodium hydroxide. We're going to employ caustic soda as a reagent to identify cations. In our next tutorial class, we're going to look at how to identify cation using aqueous ammonia and other reagents. So stay connected as we continue the practical. So when you want to identify cations in chemistry, we need a table. The format, we draw a table. On the first column, we write test. Second column, we write observation. And the third column, we write inference. So this is the format to identify cations or anions in practical chemistry. Test, the test means the experiment you're going to do. Observation, what you observe after you have done the experiment. Then inference means your conclusion. So you have to bear in mind that if you record a wrong test, if the test is not well recorded, maybe in terms of your language, you're choosing words, or use could be, maybe you're supposed to use an aqueous solution, you went and wrote solid. You're supposed to use a filtrate, and you went and you write residue. You write a different thing. If the test is wrong, no matter how beautiful it appears, your observation and your inference will score 0. No matter, they may be correct, but because the test is wrong, then you're going to have 0 in the observation. Because the logic there is, how can you have a wrong experiment and have correct result and the inference? So you have to be very careful in your tests. Although in the standard examination, just like WAEC examination, GCE examination, or any exam you're writing O level or A level, the test may not attract any score for you. But what attracts score is observation and inference. But if the test is not written well with the correct wordings, you're going to score 0 in the observation and the inference. Another thing you should know that if your observation is wrongly written, you observe wrongly, and you wrote the correct inference, especially from that question, you wrote the right inference, but observation is wrong, you score 0 in the observation and still score 0 in the inference, even though you wrote a right inference based on the marking scheme. You still fail the inference because you wrote a wrong observation. How can you have a wrong observation and have a correct conclusion? So that is the argument here. So we're going to start our experiment now. Okay, assuming we have an unknown sample of a substance, and let that substance be called C. This represents our unknown salt. You can use any letter to present it in our aqueous state. And we are trying to add sodium hydroxide to that C. So this is the way we report our work. So normally in qualitative analysis, when you are adding a reagent to a salt which is in solution, the salt must be in solution. We have to add the chemical to it in drops. We have to add drops of it before we add in essence. So let's see the unknown substance, then plot this chemical in drops. Then after adding in drops, we're going to add in essence after that. So we're going to go to the experiment and then take a salt, an unknown salt sample, and then carry out our experiment. So let this be the unknown substance which we call C. And as I told you in chemistry, this is solid. You don't do chemical tests with solids. So what I have to do, I'm going to add water to this C to dissolve it. So add a little water to dissolve the C. It's still insoluble in water. I'll now put a glass rod or a stirrer to make sure that seed dissolves. Because if you look at the board, that seed is in aqueous state. You can see the seed is aqueous, that means seed is in solution. So you don't test with solids. So make sure that seed dissolves before we now carry out our test. So seed is almost gone in the water. So we can have that. So we want to know the cation inside this seed. So you see it's gone, dissolved, giving us a homogeneous solution or mixture. Okay. Having done that, to test for seed, what I'll do is I'll collect a little amount of this seed inside a clean test tube, a little amount. Okay, there's some water there. Empty it. So that is it. Collected in a clean test tube. We'll now keep the bigger one and continue to test the small one. So that this what I'm having now is our seed aqueous. A little amount of it. So what I'll now do is I'll go to the reagent table, and this is sodium hydroxide which I'm holding. I'll use a dropping pipette and press the rubber ending tubing and collect the chemical, and then allow one drop to enter into it. One drop, or you can see make it 2 drops. So you then observe. If you come closer, you observe, you see there are some gelic or gel-like particles inside the tube, which has blue color. So have gel, those solids form inside. As I said in my previous video, when you mix two solutions, and you form a solid, that solid is called a precipitate. So you have a blue, but it's not pure blue, this is pale blue in color. So we'll go to the board and then write our observation on the board. Alright, see aqueous for this, we now write observation pale blue precipitate. Or we can say pale blue gelatinous, because that blue is having a kind of jelly nature. Pale blue gelatinous precipitate formed inside the solution. The inference means which cation or which metallic ion can give all the kind of results. It is copper 2 ion. We say copper 2 ion present. Copper 2 ion present, not copper 2 ion. Copper can still have copper 1 present. Then that is the result we can infer from this little experiment. So the next, go to the next line and write, let me draw a line here. This is a continuation to number 1. Now say plus sodium hydroxide aqueous in essence. So we are adding the same chemical now to the pale blue precipitate formed already here in my hand. That the pale blue precipitate formed. I'm now adding sodium hydroxide, the same chemical in excess to it to see whether it will dissolve or not. So the chemical is being added into it. So it's going in excess, that is add more. So you can see we have added enough. When you look at it, you can see that those jelly particles are still inside undissolved. Still inside undissolved, remain insoluble. So we go to the board and write here pale blue gelatinous precipitate remained insoluble. So having done that, our inference will also be copper 2 ion present. So this is how we identify copper in a salt. We'll have this kind of result to say that copper is present in the salt or suspected in that salt. So that unknown salt C contains the cation copper based on the test with sodium hydroxide. So we're going to do another test. Let's take an unknown salt with label S and that salt, and we're adding now the same sodium hydroxide aqueous to it in drops and then in essence. Let's see what we're going to have when we add. When we take another solution and add this chemical to it and see what we're going to have. Okay, we have another substance S, as we said, S aqueous plus sodium hydroxide. So this presents our S, which is different from the one we use as C. The C we use will have a blue color. So this is our S. So, and of course, this is in solid state. And as I said, we don't do tests using solids. We must make sure it's solubilized, it's dissolved. And that will dissolve it using, if there is a salt that is dissolved in water, use water to dissolve it. But if the salt that is not dissolved in water, it can be dissolved using an alkali or an acid. So, depending on the instruction given to you in the question. Now, this is a solid. We're now going to dissolve this substance inside water and add some water into it. Some distilled water into it. Little water, that's okay. You see that it is still, we'll still have some crystals at the bottom of the test tube. So I'll put my stirrer and turn it. Make sure I dissolve it totally to have a homogeneous mixture. Sometimes you can still use your thumb and close here and shake it vigorously to dissolve without waste of time, provided the substance is not poisonous. So you see, it's soluble now. We'll have a homogeneous mixture. Now when I'm going to carry out a test on this S, so to carry the test, we're going to add, according to the instruction on the board, we're going to add take small amount of this S, get a clean test tube and collect something not more than 2 cm cube. Little volume. So you can see what I collected. This may be too big. So I have to still reduce it. You don't have to collect so much amount, because if you collect so much amount, the result you are going to get will be misleading. You're going to get an erroneous result. So that is okay for our test. Look at the amount I collected. Then this is my sodium hydroxide. I'm going to add a drop of this chemical into this. So using the drum pipette, I didn't get it. So add a drop or 2 drops. Okay, that's all right. Then we now observe. You will look at the inside of the test tube. It appears cloudy or milky in color. It's not pure white. This is white, but that white looks like a gel. It's called white gelatinous. White gelatinous precipitate. There are some solids inside, formed inside. White gelatinous precipitate. So we go to the board and write under our observation, white gelatinous precipitate formed. Now, what are the cations that will give us white gelatinous precipitate when we add some hydroxide? There are 2 major cations that will provide this kind of observation. They include zinc 2 ion, or aluminium 3 ion. So remember that we are testing for only 1 cation in this salt. So when you are reporting your work, don't ever use and. Zinc 2 ion, that comma means or, So there should be only one cation inside it. So if you say and, that means you're telling us there are two cations in a simple salt. So a simple salt will only contain one cation. So we are suspecting either zinc 2 ion or aluminum 3 ion. Then the same thing, another important point here is you should write the symbols of the element very well. Zinc is an element, so the first letter should be capital Z, second letter should be capital N, with the correct charge +2. Aluminium, first letter is capital A, second letter small l, with correct charge 3. Copper, first element is capital C, second one is capital small u. Likewise, this one capital C and small u. So we'll go to the test column again. This time around, we're going to add the sodium hydroxide, the same precipitate will form above. We'll add it in excess, just like as we did for copper. We add the sodium hydroxide in excess to this white gelatinous precipitate that is formed. So in excess and see whether it is dissolved or not. So we'll still go back, I'll still pick back my sodium hydroxide solution and add it in essence to this white PPT. We'll add plenty of it. So you see that the substance is clear now. So we'll have it dissolved, nothing inside again. Nothing inside, not remains inside. The solid has disappeared. The gelatinous nature has disappeared. So now I write on the board white gelatinous precipitate dissolved to give a colorless solution. We still write under the inference zinc 2 or aluminum 3 present. Two of them are giving similar results, both in drops and also in essence. You can see solution remains homogeneously clear, nothing inside it. So the colorless after dissolving.